here we can see the layout of how the augmentation dots could apply all the way up to 4 dots with half notes and quarter notes all in 4/4 time. So again, the meter is somewhat significant, and again, we typically will only see augmentation dots, at least used excessively, more than 1 dot, in simple meter. Not so common in compound meter. It's kind of messy often. So walking through the math on this, we can see in 4/4 time a standard half note is going to equal 2 beats, of course. So a dotted half note is going to equal 3 beats. The rationale again behind that is that there's 2 beats for a half note, and the dot is equal to 1/2 of any note's value added onto itself, or like multiplying any given note by 1.5. So you can look at it either way. 2 times 1.5 would give us 3 beats, or half of 2 is 1. Add those two together, and we get 3 beats, because 1, again, is half the value of 2. So in a measure of 4/4 time, if we had a dotted half note, we'd be left with a quarter rest if we had a rest to fill out the rest of the measure. Let's walk through the rest of the half notes this way. So again, 2 dots is going to pan out mathematically this way. I'm going to use decimals all the way across the board. You could, of course, use fractions if you prefer. But we just talked about the 1 dot being 3 beats. A second dot is going to equal half of the value of the first dot. So not going back to referencing the note directly, but the second dot is going to be half the value of the first dot. If the first dot in this case was worth 1 beat, half of 1 is 0.5, or 1/2. So sum all of these up, and a double dotted, or 2 dotted half note is going to equal 3.5 beats, or 3.5 beats, giving us just an 1/8 note rest to close the measure out if we were looking to close it out with a rest. Of course, you could replace that with an 1/8 note, or whatever the case may be, depending on the context for the application. A third dot being added, or 3 dots added to a half note. Half note's equal to 2. First dot is half of that, or 1 beat. Second dot is half of the first dot, so just a half of a beat, or 0.5. The third dot will be equal to 1/2 of the second dot. If the second dot was worth 1/2, the third dot will be worth 1/4. Or if the second dot was worth 0.5 beats, then the second dot will, of course, be worth 0.25 beats. Adding all of these numbers up will give you 3.75 beats for a triple dotted, or 3 dot half note, leaving us this to close out the rest of the measure with a 16th rest. And finally, 4 dots. I'll walk you through the same procedure. 2 beats for the half note, 1 beat for the first dot, because that's half the value of the note. The second dot is equal to half the value of the first dot, or 0.5. The third dot is worth half the value of the second dot, or 0.25 beats. And the fourth dot will be half the value of the third dot, so half of 0.25 would be 0.125 beats. Add all of those up, and you will get 3.875 beats for this monster right here, leaving us with the 30-second rest to close out the rest of the measure with. Obviously, these dots can continue and can go on ad infinitum. So we could have as many dots as you would want to on any given note. But if you think about this, you have to think about who you're targeting with something like this and why you would want to do something possibly so deranged as this. It might be simpler to rewrite these a different way, and depending on your audience who would receive something like this, 5 or 6 dots is very, very rarely ever seen, because it can add a lot of confusion, and then someone needs to come in and, all right, the math is fairly simple, but I wouldn't want to have to calculate a 6-dotted note in the middle of a sight reading situation. I know I wouldn't prefer that. So there could be other ways, probably preferable other ways, to go even past a couple of dots. 2 dots is very common in standard music literature. 3 and 4, and certainly more, is far less common. But this is the procedure, this is how it worked mathematically, and this is how augmentation dots work here. Working over to the quarter notes in the same fashion, I'll walk you through the same. A quarter note in 4/4 time, if I keep my meter all the way across the board. A quarter note in 4/4 time is a single beat, of course, worth 1 beat. So a dotted quarter note would be 1 plus half of the note's original value, or 0.5 beats. totaling 1.5 beats. If I close the rest of the measure out with rests, here's what we'd get. A double dotted quarter note would be worth 1 for its original beat, 0.5 for the first dot because that's half of a beat, and the second dot would be equal to 1/2 of the first dot, exactly identical to what we've seen before. Adding up all of these gives us 1.75 beats, or 1 3/4 beats, and then the rest of the measure would close out like this with rests. A third dot adds in half of the value of the second dot, as we see here. Adding up all of these would give us 1.875 beats for this triple dotted quarter note, and a fourth dot would be equal to 1/2 of what the third dot was equal to, or 0.0625 beats, summing up this quadruple dotted quarter note to be equal to this, or 1.9375 beats. Notice that no matter how many dots you ever continue to add to a note, it will never double its value. So no matter how many dots we continue to add to this, we will never reach 2 beats. We will always come up short. And again, this would be pretty unusual to see something with this many dots. But understanding how the procedure works will enable you to understand if you need to perform something like this. But more importantly, it just gives us a comprehensive view of where we could be going if that works that way. These top two, naming up to 2 dots on any given note, is a very common procedure though, and we need to understand this. We'll talk more about placement in a little bit, but a dot always follows on the right side of a note if we have to add a dot to a note, like so. You never put it on the other side, and it doesn't matter where you place it. And I'll talk about that a little bit later when I talk a bit more comprehensively about it. But looking at a half note in question in 4/4 meter, this would be equal to 2 beats all by itself. So adding a dot, what that does, an augmentation dot, what that does is it adds value to the note. How much it adds depends on your meter. It depends on the note that the dot is being added to, of course, and then its value within that meter. So in this case here, what a dot is, what the first single dot is it adds half of the note's value to itself. Half of 2 would be 1. So collectively, this would be worth 3 beats, a dotted half note, because the dot would represent half of the original note's value, half of 2 being 1, add them together, we get this. Another way to look at it is you could multiply a note's value by 1.5. Or 1.5, and that will give you the same answer, of course. What if, though, we had more than 1 dot? Like a double dotted note. These are actually rather common. When this occurs, this second dot is worth half of the value of the first dot. Not back to the original note, or you could look at it as 1/4 of the original note if you prefer. I kind of like to look at these in chains of halves. So if the first dot is worth a half of the original note's value, the second dot is worth half of the first dot's value. Or in other words, half of 1 is 1/2. I'm going to use decimals here. Could use fractions if you prefer, but I'm going to go with decimals rather. So adding all of this up will give us 3.5 beats. A double dotted half note will be worth 3.5 beats in 4/4 time. Let's continue. If we add another dot, we'd be adding 1/2 of the second dot's value. Half of 1/2, or 0.5, would be 0.25. So adding these together will give us a total of 3.75 beats. 3 3/4 beats. Triple dotted. And looking at the last one, let's go on to 4 dots. We could go on indefinitely. Notes can be dotted up to any value, but after a while this gets terribly excessive. It would be very hard to read, very hard to deduce how many beats it's going to get. What one would probably start to do is start making some guesses as to how long they think it should be, and that could be pretty messy. So let's look up to 4 dots. And that's the most I've really ever found in standard literature, which is included in my book if you take a look at the excerpts. But the most I've really found comfortably is 4 dotted notes, and these are in late 19th century pieces. I believe the example I used was from Liszt. People were pushing the extremes, notation-wise, not just tonality and other features. So I found some examples like that, but they're not very common to find. So a fourth dot would be half the value of the third dot. So half of 0.25 would be 0.125. I think I'm going to stack all of these ones. 2 plus 1 plus 0.5, right? Plus 0.25 plus 0.125. We can do the math pretty easily here. Or 3.875 beats. Looking at quarter notes in a similar fashion, a quarter note is worth 1 beat in 4/4 time. Add a dot, we get half of the note's value added to itself, or 0.5. So this is going to equal 1.5 beats. Add a second dot, and we're adding half of the value of the first dot, or 0.25, and we'll get 1.75 beats. I think I'll add them down the line. And if we go further, we're going to add a third dot. We get half of 0.25, or 1.125, and that will give us an answer of 1.875. So adding a fourth dot to this quarter note is going to add half of the value of the third dot. Third dot was worth 0.125 beats, so a fourth dot would be worth 0.0625 beats, and summing up this is going to give us, that's right, a little slow today, 1.9375 beats for a quadruple dotted quarter note. And we could continue ad infinitum, as I said before, and we could look at other values just the same, other notes just the same, like for instance an eighth note is already worth a half of a beat. If we add 0.5 and half of 0.5 together, we're going to get this, or 3/4 of a beat, and so on, and we can keep adding the same math as we go forward. The point here is that you need to understand the principle of how these dots work. First dot is always half the value of the original note's value. Second dot is half the value of the first dot, so it always points back. Third dot is always half the value of the second one, and the fourth dot is always half the value of the third, and so on.